Thank you for joining me today. My name's Steve Law. I'm a senior geologist with Sequent, based in the Perth office. My background is in resource geology and mining geology, and today we'll take you through the new Leapfrog Edge resource module. Before we go into the software demonstration, I'd just like to present a brief presentation talking about where Edge can benefit you and how it fits into Sequent's workflows. Sequent works across all different sectors. Today we'll be concentrating on the mining and minerals sector, which basically uses Leapfrog Geo. We also have Leapfrog Geothermal for the energy market, and recently Edge was introduced there as an option as well. And we have in the civil and environmental sector, we have Leapfrog Works. At this stage, Edge cannot be used with Leapfrog Works. Most of you are familiar with Leapfrog Geo, but Leapfrog Geo and now Edge are part of a whole ecosystem for Sequent. The basic building blocks are Leapfrog Geo, Leapfrog Works, and Leapfrog Geothermal. And Leapfrog Edge is not a standalone option, it is a module within Leapfrog Geo and Leapfrog Geothermal. And it is the main engine used by geologists and modelers to produce the 3D models. Sitting above that now, we have Sequent Central. That is a system that helps organize our projects and is a fantastic tool for people to share the same projects across different parts of their organization at the same time. And it's also useful for collaborating between especially different locations. People can have access to just looking at the model, or they can have access to working with the model. Sitting above that again is Leapfrog View. Some of you may be familiar with Leapfrog Viewer, which has been available for quite some time, but that one required you to download the software onto your desktop. Leapfrog View is a browser-based version of this and enables you to share your projects in the 3D environment simply by people having a look at a browser. There's still secure linkages to share so that only the people you wish to see the information can do so, but it also has some great tools for sharing and collaboration. We're going to focus today on Leapfrog Edge, but I will be using Central as the platform to access the project so you'll have an idea of how it looks. And towards the end of the webinar, I will just give a brief mention on how you can restructure the way you manage your projects if you're using Edge and Geo at the same time and you have Central available. Main reasons why we might want to consider using Edge. It has all the same capabilities or efficiencies and advantages that Leapfrog Geo has. Some of these include time efficiency. It is not a difficult program to learn to use. As you'll see today after the demonstration, it has a quite intuitive interface and workflow. And as always, the initial models can take time to build up, having to go through all the standard resource estimation steps that we need to follow. But the time efficiency really comes in after the original model and when you're working with updates, because everything is automatically linked to your data, to your geological model, then the associated block models will update as well as all the validation reports and subsequent resource reporting tools. Integration is a major importance, so rather than having to jump in and out of various softwares to do the different aspects of a resource estimation, it's all done in the one spot. You don't have to worry about conventions from when you transfer, say, a variogram from one package to another. It's all inbuilt and ready to go. And the most significant benefit is the visualization. We've carried through the Leapfrog Geo visualization tools and benefits to Edge so that at all parts of the estimation process you are able to see what's happening with your data in the 3D scene and vice versa as you fill in different forms and tables. Leapfrog Edge, we still go through the standard process that we use for any resource estimation. So with the underlying geology and the geology model is extremely important as always, and we can look at our compositing, our exploratory data analysis, variography, the actual estimation parameters and then the eventual validation. But rather than having to work in a continuously linear workflow, and sometimes we do get, as resource geologists, lost in the numbers, we were always with Leapfrog Edge and Geo together, keeping the geology at the forefront as we work through the process, so we can easily step backwards and forwards between the model and what we're trying to achieve with the estimate. And this is done in a very visual way, which helps us work through the whole process. Today in the demonstration, which I will start in a moment, we are going to at least briefly cover all of these different steps. So I'm going to try and show you the entire workflow from beginning to end. I won't be going into some of the finer details of how you need to do this, and at the end of the presentation I will show you how to be able to have access to learning some more about how Edge works. Areas in which people are currently using Edge. So it took about 3 years of development and was first released in late 2017. Since that time it's been undergoing continuous improvement, and we've had quite a few people start to use it now. Some of the key areas it's being used in are early evaluation or during resource infill drilling. So it's great, even with sparse data, being able to generate results and at least give you an idea of what your resource may be in the future. With resource infill drilling, we've had some clients use it as they actually do the drilling. They input the results as they come in, and they get an impression of how the block model may change, and then they can modify their drilling program a little if they find that one area of the resource isn't really changing, no matter how many holes you put into it, but it might unexpectedly point to some other open areas. So rather than having to wait a few months after you've done all the data input and the geological modelling, you can get some at least early ideas during the drilling. Another area where people are using it in is grade control. So this is where the dynamic factor of it is great, because it's already linked to the database and the geological model. As soon as the new data goes in, the block model will update and you'll get instant reports on how things are changing. And then it is being used for standard resource estimation and reportable resources. At the moment, it's been used in other areas of the world, where we've got quite a few NI 43-101 reports now started to use Edge as the fundamental software that they're doing their reporting on. So I will now go into the software presentation. Okay, so what we're looking at here is a screenshot of what Central looks like. So I have just downloaded from a central server the model that we're going to be working with today. What Central does is it basically maintains a copy of all the projects. So since the very first time that I started working on this project and working on either a geological model section of it or the estimation, it's storing the results so that at any time we can go backwards and see what happened, say 6 months or a year ago. When I want, this is the most recent project, the one at the top here, I can download that, which I've already done. That downloads a copy directly to your computer. So this is how we can have multiple users using the same project, whereas standard Leapfrog Geo, that's not possible. And then people can work on different aspects, say the geology model, the estimation, or even the fault modeling, and then does take some management on making sure all those things get put back together again. So I'm going to open up this project here. Okay. We're going to be working with a fairly simple model today, just so that we can get the key aspects of Edge across to you. So what we're looking at is a simple set of drill holes. We've got assay data, we've got copper data in this instance. A simple geological model has been made up. Now ideally, Edge, the idea is that you do have a geological model within the same project or accessible via Central, but you can use Edge directly on imported meshes. So if you've got a wireframe that you've brought in from another software, so the domaining's been done somewhere else, you can still import that into the meshes folder of Leapfrog and run the estimation purely on those. As long as you've got the drill hole database that you need to use and some kind of solid volume, then you'll be able to run an Edge estimation. We have various tools for understanding our data prior to starting the estimation, so running an exploratory data analysis. So we can do this at different levels. We can do it at the database level. So for instance, if I want to know a little bit about my copper data up here, I right click and I can look at my statistics. And because we're just looking at a single element within a table, it just shows us a histogram. These can be detached, and as long as I have that information visible in the scene, we'll see that if I highlight part of the histogram, for instance, I would like to know where these higher values are, then that data is interactive with the 3D scene. So any part of the histogram that we highlight, the corresponding intervals will show up in the 3D scene. So that's one way of understanding the spatial distribution of our data. This is available through all of our graphs. We have other ways of looking at our data. In terms of just visualizing the information, as well as fixed radius. So we're basically just looking at a solid cylinder. If we've turned on this little pink button here, we can go back to just traces, or we can make the line more solid. And you can change the size of that. The other alternative is we can use the other elements that are available within our table. So in this instance, we've got gold as well. We can display by copper colors, but by the radius of the gold content. As well as that, we also have graph capability. So underneath your survey table on the left-hand side, we have drill hole graphs. If we drag them in, you can see here that we can display we can look at gold, we can scale it so that the bars will show up. I'll just show that in 3D there. And we can offset, so if we have put a cylinder on, we can move it a little bit away from the drill hole traces. Let's go into if we have a look in section, you can see that we've got the graphs on the side. Copper displayed also as color, and the discs are also done by a scale. If we're using merge tables, where we may have merged together lithology with assay data, so in this case I've got some lithology and assay data grouped together, well then this will give us access to some other graphing features. One of the most useful ones is the box plot. So we tell it we need to have a numeric column, we need a categorical column, in this case it's rock, and we can see a box plot showing the information. So this is a great way of looking at new data sets. If you've got a lot of codes you're unfamiliar with, you might quickly be able to determine which are the most important codes for relating the assays back to the geology. If you want to just get the numeric information out of there, in the statistics, there is a table of statistics, and you can see the means, etc., for all that data and anything that's available within those tables. We'll now move more into Edge. So the way to know whether you have access to Edge is whether or not you have this estimation folder present in your project. If you just have Leapfrog Geo on your license, then that estimation folder will not show. But once you have Edge activated, it will. And everything that we need to do to set up Edge parameters is done inside this estimation folder. All the results, though, are viewed via the block models. If someone has used Edge and created a block model, you do not need an Edge license to view the results of that. So that next time you open that project, even if Edge isn't available, you will still be able to look at the block model results. And generally in that instance, the estimation folder will have a little restricted sign standing next to it. Okay, the whole premise of using Edge is working on a domain by domain basis. So the way you build up your Edge is you right click and you basically create a new domain estimation. From there you pick out your domain. So this shows here that it can be accessed either from anything that's within the meshes folder. So if you've got a wireframe from elsewhere, just put it in here and you can access it. In this instance, the blue meshes mean that these are being accessed from a different project within Leapfrog Sequence Central. Also, any volumes within your geological models. So in this case, it's the output volumes, but we can also use solids like intrusions or veins from within the surface chronology as well. We can also access any of the grade shells we may have generated from a numeric model. So all of these things are available to choose from. I'm just going to pick out this early diorite. Again, in terms of the assay data, it's sourcing anything that's within your geological database. So you've got your raw data, you've got any data that you've made a composite file from at the database level, merge tables, and we can also use point data within an estimate as well. So in this instance, I'm not going to composite at this level, I'm going to do it later on. We have two options for compositing. You can either do the compositing prior to running the estimation, so that's setting it up under the database, under the composites folder, and running our standard numeric composite tools. Or we can composite on the fly, which is what I'm going to show you today. I've used copper %, and this is where we can choose to use compositing here. At this stage, it is usually always within a boundary, so it is going to honor the boundaries of the particular domain that you're working with. And then we have our standard compositing tools for determining what we're going to do with the little pieces at the end. So we can either discard, add to the previous interval at the end of the hole, or distribute it equally across the whole domain. You can try different ways to see how sensitive your data is to compositing. We always end up with a default name at this stage, and this becomes the name for the estimation folder. This can be edited if you're needing to export into other block model, say take your block model from Leapfrog and place it into one of the other software packages. The naming here will need to align more with what that package will accept. So Leapfrog doesn't care about sentences and commas, etc. But if you've got a software that can't handle more than 6-letter variables, then you'd need to restrict this to the 6 letters to make it a lot easier to export later on. Okay, I'm not going to keep that one, but This was just to show how it's made. Once we've got an estimation domain set up, it basically creates a new little folder with all of these components below it. We can see it's similar to the way a geological model works in Leapfrog Geo. So this is a little self-contained working area. We have the domain, so we can drag that over, and straight away we can see, okay, that's the domain that we're working with. What it does then, it takes the drill hole values or the composite values and it turns them into point values. So I'm just going to turn that off for a sec. So now we're just looking at data confined to the domain that we chose, and we can still use statistic tools now on this one, and this will give us domain statistics. So we'll go to the histogram. So we can see here that we've got a nice, fairly normal looking histogram here. Again, this is interactive. So as we pick the higher parts of the histogram, it'll show us where they are on the scene. Just need to stop it. And so and the values are shown down below, so it shows you, it links to where they are coming from, so we can see that these things are coming from the copper percent back up and through here. So there's always those linkages that you can follow back to find out where the data is actually coming from. Spatial modeling is our wording here for variography, so we'll have a look at that in a moment. We now have a variable orientation functionality, and this is like locally varying orientation. So this is where the search ellipse actually changes relative to a particular guiding mesh. So if you've got, for example, an undulating layer, then we're still restricted to a variogram in the sort of global trend of that. But as we search for our samples, it will vary the orientation of that search ellipse and taking into account the underlying variogram, and you potentially have better selection of samples. We'll have a look at that a little bit later. Sample geometry is our declustering, and then the driving force of this folder is the estimations folder, which is where we set up all the parameters for inverse distance, kriging, and nearest neighbor is all available. We'll have a quick look at variography. So within the spatial models folder, you can have as many variogram models as you like so that you can test different variogram parameters. We'll have a look at this one that's in here. Just expand that a little. Okay. So we use fairly standard sort of variography modeling tools. So we have one radial map. Now this is not in any set direction in terms of, I'm not looking at strike or dip azimuth necessarily. It's looking in the plane of best continuity, and we can help this set up right from the beginning within Geo itself. So if I just move this across for a sec, I'm just going to copy this one first so I don't destroy it. Okay, so I'm just going to go into the copy so we can see how this relates to, as soon as we open up the variogram, we can see the corresponding ellipse in the 3D scene. So we can have our data open, we can have our domain up, and we can see how the ellipse is relative to what we're trying to work with. So if we can't accidentally rotate things in 90 degrees to the way we really want it to go. We have three components. So here we have this left-hand side, we work out the parameters that we need to produce the experimental variogram. So each of these graphs can be looked at individually, and we can set that lag distances, the number of lags, angular tolerances, bandwidths, etc., to basically get a set of points that hopefully we'll be able to model. The actual modeling side of things is done up here in the top part, and We can either model to raw variance, or we can standardize that to 1, and the sills, everything gets normalized to 1. At this stage, we can use 2 models plus the nugget to define the model curves. We do have, in terms of experimental variograms, we have variogram and we have the parallelogram, and then pairwise as well. So we are working on normal scores, transforms, and the prototype is ready in testing. So we're hoping to have that available in October this year. So you'll be able to apply a transform to your data and then do a normal scores variogram, which will help a lot, especially in gold and some of those other elements. So at the moment though, we've just, variogram is usually the one I would use. Set up your parameters to try and get the, if I change this to say 20, you'll see that the lower axis will go out to 1,000. We can see our data points fall apart after 600 meters. So I'm not too interested on what's going on past there. So it takes a little bit of playing around sometimes to get this to what we want to look like. In terms of the radial plot, often what we can do as a starting point is, if we're, for instance, looking at this data and we think that the plane of continuity is running down through that way, that's the strike. Have a look in dip. Let's open that out. And just for the sake of it, maybe the dip's this way. We can set a plane, and then back in here we can go set from plane. So whatever the last plane was that was in the 3D scene, we can set that, and this will change. As we move this around, we will see, I'll turn my ellipse off. As we move this around, you'll see that the ellipse is moving in the 3D scene as well. Though this tends to be just changing the pitch up here, because we've already set the dip and dip azimuth by our plane. As we change any of these things in here, I'm going to turn this one off for a sec. You see that as we change, I'll zoom in a little. I can click on the green one and you'll see that that's changing our semi-minor direction. The blue one is our minor direction, and where's the other one? There it is. Our reddish brown color is our major direction. If we're looking in our axis aligned part with these three, as we move any of these tools, you'll see that that is changing the ellipse. So you'll always know how these graphs relate to the 3D scene. So, because this direction of continuity doesn't necessarily mean that this is strike and this is down dip. This could be down dip with the plunge direction being continuous, and strike and dip could be somewhere else. So you can always see what's going on. As soon as you get to doing the second structure, so it's another spherical, you can't click on the ellipse to drag it around. So sort of sort that out when you've just got one structure, and then the ellipse always shows the ranges of the second structure. The first time that you go into this, you actually need to add a downhole variogram. So under this button here, you would add, and then you would add the downhole variogram. In this case, we've already got one. It's not a very good one for this particular data, but this is where you can set it. You can set it either manually using the slider, or you can just manually type in the numbers up in here. Any of these numbers can be manually changed, and adjusted. So I would normally make sure that these things add up to 1. You can rename it up in here, and so you can try a few different types of variogram models if you're not quite sure which one to use. So I'm just going to discard that one and delete it. Declustering, I won't touch on this one too much. Basically, we do a new declustering object, and if I'm looking at my data, I can see here I have to set a cell size effectively. So for instance, most of my data here is quite widely spaced. I might be looking at, if I look at 120 so 120, it shows me what data I'm getting within my cell size. We've got ellipsoid and cuboid. Cuboid is effectively exactly the same as cell declustering in other softwares. We have got this overlapping window option, which is good to use. It tends to smooth out steps that can occur in cells. So at the edges of the cells that you're using, you can get artifacts. This helps to clear these away and may help you get better graphs. We don't have an optimizing function at this stage, but the easy way to go is, if, for instance, I've done that one at 120 meter spaces, and then I would just copy that one, and I could change that one, say, to 180. And then we can right click on there, look at the properties, and it will show us what our declustered mean is. So we've got a naive mean of 1.08 and 1.06 for the declustered mean at 120 meters cell size, and for the 180 meter cell size, it's 1.053, so not that much difference. So we can see that there's a little bit of clustering happening in here, but it's not having a huge impact on the naive mean. So that's just some information we can take forward with us when we try to validate our block model. We can apply these declustering objects directly to an inverse distance estimation. That's optional whether you wish to do that or not. And all it's doing is assigning some declustering weights to the samples to apply during the estimation. The real powerhouse of the Edge here, though, is in the estimation folder. So this is where we set up either a new inverse distance estimator. So we come up with the interpolant. So this is where we say it's inverse distance squared, cubed, etc. If we have a declustering object available, we can choose to use it here. The ellipsoid is set here. So this is, in this case, I'm just going to match one of the other searches that I've set up before, but you can change this to whatever different strike that you wish, and this is where you can define how far you want to look. We have standard search type limiters, so we've got obviously a minimum and maximum number of samples. We have outlier restriction availability, which is where if, for instance, you've got scattered very high grades a long way away from the blocks you're estimating, you can tone these down. So for instance, if I look back at here, I've got 200 by 200 by 60 meter search. So if I put in 50 here, it's saying if I reach 50% of that search, then any samples beyond that that are greater than 5% in this instance will be cut effectively to 5%. So it's a way of clamping information that's being sourced from a long way away from your block. I would only ever use this usually on second or third passes, but it is available. We have sector, so we have quadrant and octant searching, where we can define the number of samples per octant, and this can help. This is another way of declustering data we could use for inverse distance or even in kriging, even though kriging inherently is declustering it for us. And then we have drill hole limiting. So this is where you can limit the maximum number of samples you want to use per drill hole, bearing in mind all these things tie together. So when you use this, you have to be aware of what you're doing with your minimum samples. Outputs. This is where Edge varies from other softwares. Usually when you're defining a block model elsewhere, you need to set up a whole heap of different variable names to store things in the block model. When Edge works, it basically stores the grade variable, that is the name here. But if we want to store things like average distance to samples, number of samples, we just tick these boxes and they will automatically be stored so that you don't have to make up new variable names for all those different things. The only other tab we haven't touched on is this value clipping, and this is our top cutting. So again, you can use top cutting prior to bringing the data in. So if you've got a complex workflow for that, you can set up the composite files, do the top cutting on those beforehand, and then you'll just use those top cut composite files and not use this tab at all. But if you within particular domains and you can set variable top cuts per domain, this is one area where you can do it. Just tick that on, put in whatever the top cut value is that you wanted to use, and it will do that. You don't have to use a lower bound if you don't wish. So that's another area where you can apply that. So I'm just going to turn that off. What I've got here is I've already set up a few different estimators now. So I've got some inverse distance estimators, and I've got ordinary kriging estimators that are using exactly the same search parameters, but they're just kriging. So then I can compare inverse distance versus kriging in my end result. I can see here that I've got pass 1 and pass 2. So I'm going to open up the kriging one so that we can have a look quickly at how kriging differs from the inverse distance estimator. And I can open both of these up at the same time. So on the interpolant here, you're choosing ordinary kriging, but you do have the option of using simple kriging. And if you do simple kriging, you just need to type in the mean value you want it to use. Discretization parameters are set up here, and the variogram you wish to use. Because we only have one in this particular folder, that's the only one it can see. But if you have a few available, you choose the one that you want to have a look at. If you've forgotten what that variogram looks like, then you can just view it, and that'll show you what your ellipse is looking like relative to your data. Again, if we have a look at the ellipsoid tab, this has been set to the correct variogram model. So I'm in the ordinary kriging. So I'm looking up here, I've used this variogram in here. That will then set up the correct direction. You can change the maximum, minimum, intermediate and minimum directions. So if you want to start off with, say, 2/3 of the maximum range of your variogram, and then on subsequent passes, in this case, on my second pass, I've just doubled the distances here, and then in the search parameters, I've used 4 samples and 20 maximum with a drill hole limit, but I've reduced the number of minimum samples to use on the second search. And sometimes then I would even remove that drill hole limit, and that would be the second search that I'm going to use. Let's cancel those so I don't change anything. So we have a series of estimators set up in through here. Another functionality we have then is how do I combine 2 passes together? So at the moment I can look at the results of pass 1 and I can look at the results of pass 2, but I want to be able to see the combined. So back at the top level, we can make new combined estimators. If you're used to using merge tables in Leapfrog Geo, it's a very similar approach. You basically select the estimators you want to join together. So I wanted to join inverse distance pass 1 with inverse distance pass 2. You can give it a name, and it will automatically store the domain and the estimator number so that you can display what blocks were estimated on the second pass. Again, you can untick these if you wish, but you can also store average distance for the combined estimator and say number of samples as well. So all of these things can be ticked on and off at any time. If you don't do it when you first make it, you can just come back later on and open it and just change the tick boxes and tick them on. You can see here that we can store things such as kriging variance, kriging efficiency, slope of regression, etc. I'm just going to kill that one. So think of the estimation folder as your parameter file. This is where you set up all your different parameters. I've just set one up for my copper. You don't have to go through this whole process from start for every single domain and every single element. Once I've got one for copper, I can copy that entire folder and simply change it over to gold, for instance, in this case, and go OK. It will then set up all the same estimators with the same parameters. We would obviously need to go in and edit our variogram because it won't be the same, but really that's all we probably need to do. We might make a few tweaks underneath the estimators in here. As you can see here, that most of them, some have changed their name. Because I changed the names earlier on, I do need to edit these, so I'll need to open these up and just change the name there to AU. So if we change from the default values, then the names do need to be changed. But I'm going to delete that whole one now. So it's not difficult to set up multiple folders. We can set up subfolders so that you could group things by domain or by element. So if you've got 3 domains but 5 different elements, you could set up a domain subfolder and put all the different estimates underneath there. Okay. I do have another one set up here, which is called gold in regolith. So let's have a quick look at that one, because that will help us with our explained variable orientation. So I bring in the domain. Basically, this model had a regolith that's just basically draping over a mountain. And in that, we had some gold values, a fair few on this side, but not very many on the other side. So I want the estimate to have at least a go to see whether it can curve around this shape. So we still set up the variogram in the normal way. So the variogram is restricted to one direction. Oops. So if we have a look, the resultant variogram looks like this. So it's still within that one plane. So this is not unfolding what we're doing with the variable orientation. So you still are restricted to a variogram in the best orientation that works for your data. However, we then set up a new variable orientation, and what we do is we get it to follow a mesh. If we're working with veins, we can actually pick the vein that we want it to follow, and it'll use the hanging wall and footwall surfaces of those veins. If we've got a stratigraphic sequence model, we could use that, or we can use any other mesh that we might have in our meshes folder. So if you've got a particular warping that you want to follow, you would create a mesh first, put it into that folder, and then we can use that one. It's very similar to the functionality of structural trends in Leapfrog Geo. Let's cancel that one and show you the one that we've got. So I'll just open this one. So again, you can edit these. So I'm using the actual regolith surface, which was a mesh that I'd stored in Central from somewhere. I'm using the variogram model that I'd made for that. And then we can visualize that either via an existing block model, or we can just set up a custom grid. Let's try 20 meters by 20 meters. And I haven't got a very big Z extent, so I'll use something a little bit smaller. And we can visually get an idea of what that's going to look like. So step down. So that shows us all these little discs. And if we have a look in section, you can see that this is now, instead of when we do the sample selection, only being able to follow the variogram. I'll just bring that one up again. So instead of only being able to use this size ellipse, it'll take these parameters and then rotate them into this orientation. So if there were samples in this area here, it will be able to find them rather than going this way. And then we apply this variable orientation later on at the estimator. So I'll open this up. This is a Kriging estimator. So underneath the ellipsoid, basically it overrides the orientation of the variogram, and we'll use this variable orientation, and that's all it does to apply this to the estimate. So that's how we set up all our parameters. So the next most important part is how do we visualize this and get it to run effectively. This is all done under the block models. We have two types of block models. So we have regular block models, which are just standard blocks, or we have sub-block models. If I make a new sub-block model, all I'm defining at this stage is the shape of it and the block size. So you can see here I can assign a parent block size and I can assign sub-blocks. So in this case it's 400 divided by 4, so that would be 100 meter sub-blocks. So you can see that's the parent block size and this is the sub-block size. We do have a variable height option, so this is handy for sub-horizontal systems where you might want to have just one block height per seam or domain, so that can be used there and it works quite well. Subblock models can be rotated in dip and azimuth if you wish. So I'm just going to open up the one that we've already defined. So again, at any time you can go back and make changes to this definition. I'm just going to bring in our data again so we can see it relative to our data. There we go. So you can see it shows us the block size. So I've just got 10 meter parent blocks with 2 meter sub-blocks because my domain was just a blob, so I didn't have to get too detailed around the edges there. These two tabs are the critical ones. So we have sub-blocking triggers. So this is what are we sub-blocking on. So we're usually sub-blocking on our geological model. In this case, I'm just sub-blocking on the mesh of my early diorite, and I'm sub-blocking on my regolith. I'm also sub-blocking on some stope shapes. We'll come back to that later. Evaluations is basically how we run the estimate. Anything that we want to display inside the lit block model needs to be brought across from the left-hand side over to the right. So I want to be able to see the results of my Krieged regolith gold. I want to see both passes of my inverse distance and my Kriegging, but I also want to see the combined results. So all of these things are just originally they'll be sitting over here on the right left, and you just bring them across to the right. You can shift these around anytime. I will often create a block model with all these separate passes, do my validation, etc. from there. But my final reporting model will just have the combined estimators in it, and it makes it a little bit tidier. If you bring in a geological model, in this case, I haven't brought it in, oops. So I can bring across my whole geological model, and that basically flags my geology ready to be used and displayed. So anything that's on the right will be displayed later on. And we can flag by sub-block centroids or by parent block centroids. The categorical type always default to sub-block centroids. Up until version 4.5.1, You could only do it by parent block centroids for numeric estimators, but now with 4.5.1 that just came out, you can now use subblock centroids on numeric items as well. So I'm just going to go cancel that because I don't want to actually change my results. To view what's happening, so there's no run button or anything like that. As soon as you put them onto the evaluations, it's run. You can come back to that at any time. You can either just open up the whole block model and go to your evaluations tab, or you can just right click and go evaluations and do the same thing. The key thing is that if you do something up in the estimation folder and make a new domain estimation or change anything here, you then make sure you go back to the block model and evaluate the new item that you just created. They don't automatically link through. To look at our data, we just drag the entire subblock model into the scene. And we can then look at everything that we've told to store is now stored in through here. So if I want to look at my inverse distance copper, that will show me the results from pass 1. If I wanted to see the results from pass 2, I could see them as well. So what's happening, yeah, that's fine. Let's change it back to that. And then the combined estimator, which is the one we really want to look at, is this one here. So the combined estimators will basically allow you to look at all your domains at once. So if you've had 5 different domains and they're all discrete, if you look at them individually as this, then you'll just see one at a time, but the combined ones will let you join them all together, so you'll see multiple domains at once. This status button comes in for each one, and it basically shows you what has been estimated and what has not. So within this domain, the white blocks are estimated, but the purple blocks are not, because they don't meet the parameters that we've asked it to look at. So one useful tool that's great for trying to understand what's going on is the block interrogator tool. If we click on any of these blocks, I'm just going to take that away. All I've got in the scene at the moment is the block model that I brought in. I click on any one of these blocks, it will show me a big list of what's there, but you'll see here that there is this interrogate estimator. It will show me the ellipse that's been used to estimate around that block, and we can filter the block model with this little button here, and I usually just turn that ellipse down a little bit. What it does is it shows me the samples that have been used for estimating this block. I'll just turn off the search completely. So under this filter here, it says it's found 78 samples, but it's only used 10. If there is a problem, for instance over here, it shows you the weights that have been used, it shows you the distances you can sort, so you can see that we're varying from 68 meters to 142 meters. If there was a sample that was quite high grade and it was at a long distance, you might be able to use that to say, or maybe I want to use some clamping in here. If we've got negative weights, it will show them up as red in the weights column, and you can investigate what's going on with those. You can directly go to the estimator. So if it is pass 1 copper that we're interested in, it might be the Krieger one that you want to look at, you can open it directly up, open estimator, and it'll take you back to that spot, and then you can change some of these parameters. You might reduce your number of samples, put in a selection, and it'll update straight away, and you can test to see what is happening. It's handy for if you're getting an unexpected area of high grade, it'll show you where those high grades are coming from, and you can choose to change the parameters a little to see if you can filter them out if it's not appropriate, or change the parameters in some other way. So either by clicking on a block and hitting the interrogate estimator, or if you right click on the block model, you can go directly to it from that option as well. You see that right clicking on the block model gives us a few other items as well. We've got calculations and filters. We're trying to get away from using macros as such, but we have a lot of functionality in terms of building up calculations and things that we can use in the block model itself. We have 3 different types of item. We have variables. So this is something like metal price, like gold price or silver price, which you can predefine. A variable can be used in a calculation later on. You just cannot visualize that in the block model. Then there are 2 types of calculation. There's a numeric calculation and a categorical. Basically, if the answer is a number, it's numeric. If the answer is a word, it's a category. And then we have filters. Filters are same as query filters in Leapfrog Geo. So you can see here down in the right, oops, cancel that. When I'm viewing my block model, you've got some filtering happening down in here. So you can filter by just values. So if I want to see just where is everything, say above 3%, and apply that, it'll just filter those blocks out for me. But if I need something a little bit more advanced, like a combination of greater than 3% copper and greater than 5 grams gold, then I can build these filters over here. So I could go ID combined greater than 3, and we've got syntax helpers. I'm sorry, it's not on the screen. And some other variable. This isn't going to do anything for me. Let's go that one, less than 1, and that will make that filter, and then that will be available in the drop down list. I've just called it filter over here. It's probably not going to display anything. Oh, it's a couple of blocks up in the regolith. So if I turn that filter off, it comes back to there. So that's how you do query filters. We can delete that. Now I've set up a couple of filters here just to get calculations, just to get an idea. So we've got, when we're doing reporting later on, it does not like having empty blocks anywhere in the model. So this is one way of getting rid of them. You can either do a final pass in your actual searches and say, use one sample and make sure that you're getting some sort of value within your blocks. Or this is a way of defining default values to blocks that have an estimated, that are sort of out around the edges. So I'm basically saying here, if I've got a result for the inverse distance combined, then use it. Otherwise, use 0.1. And I've done the same for a kriging estimate as well. This is another way we can assign like SG by domain if we don't have enough information to actually estimate SG. So I could put SG in here. I can insert an if statement. If statements are quite handy. And every item that's available within the block model to use within a calculation shows up over here on the right. And then this is just syntax help if you need it. So I'm saying that if for instance, my early diorite, sorry, wrong way around. I'm saying if my geological model equals early diorite, then my SG will be 3, and otherwise I might make it 1 as a default value. And I'll just rename that one SG temp, and I hit save. Down in the block model now, we'll see that that is automatically available to us, and we can have a look at SG temp. And I'll turn off the filter. It's not very meaningful, but if I just change that to 1.2, something went wrong there. But that's not a very reasonable one, but that's the way we would do it. Let's delete that one. Just displaying the wrong thing. Okay. Takes a little bit of getting used to, but they're quite intuitive after you've used them for a little while. Classification in this instance is just trying to get an idea of how we might classify. So I've said I'm using the number of samples that were stored when we ran the kriging and the average distance to samples, give it some parameters, and assign measured, indicated, and inferred. If we have a look at the results of that, there's classification in here, a little bit spotted dog, but it does show you the 3 different colors. So the colors there. So we've got measured as green, indicated red, and inferred as orange. So any calculations you make, straight away you'll see that they show up down here. If we expand our block model, you'll see that we've got all the evaluations, we've got our calculations, and then the last thing we'll cover is some of our validation tools. So we've got grade tonnage curves, and we have swath plots, and ultimately reporting. New ones of these can be made by right-clicking, new grade tonnage graph, new swath plot, and once you've made one, you can just open them up and go back to the, okay, I haven't done a swath this one, so I need to, okay, I'm just going to use constant SG in this instance. And I've got 2 curves added, so I've got an inverse distance and I've got a kriging one here. So you just choose, if I want to add, I just pick out of all my items which ones that I want to look at. So I could look at just the first pass, copper, and give it a name, and then I can see what they are there. These things can be copied. So you can actually copy the image, but you can also copy the data so that all the underlying information that's going into this graph can be put into Excel. So if you have your own format graphs to use, that you'll be able to do it that way. And again, you can store as many of these as you like. There's no save button. You just close it and it remains there. So now if I open that up again, it goes back to where we were before. Swath plots, if I open that one up, okay, so this one's been set up. So you choose your numeric items. So in this case, I'm just wanting to compare my inverse distance and my ordinary Krigg values on pass 1. That lists them down here, and then we can turn on and off what we want to look at. So we've got, this is volume of blocks, so we turn that one on, and then this is actually the values. Down here, we've got the actual composite values. So when you first open that up, they won't be on, and you can turn those on. So we're looking at composites and then the actual estimates. So we've got inverse distance and kriging. It's in the X direction, the Y direction, and the Z direction. So you only have to set this once and all 3 directions will be shown. And this was developed to be used in 3D. So they've done it by swath number. We have asked to get the axis changed to northing, easting, and RL, but at this stage these swath numbers, let's go, what am I looking at? I'm in Z direction here, so you can see that there's stripes, these swaths, and if there was a particular area you were concerned about, you can narrow down where that is visually. So now we're within this part of the model. If we swap around into the X, you'll see that we're just seeing, if I look down, that's the X swaths, and if we look, Y swaths, and then this is the X swaths. So you do get an idea of where you are. Again, these can be copied. The copied data comes out. Now we can't display number of samples used on the graph, but that data does actually export when you copy the data. So you get the volume and the number of samples. So you can put that into your own spreadsheet if you need to. So again, you can store as many different types of swaths as you wish. The swath size is based on the parent block size. So I've got parent blocks of 10 meters. So these are 10 meter swaths. If I make that 5, then I will end up with 50 meter swaths, as you can see there. Okay, so 2 last important points I want to cover is how do we get numbers in a report out of this, and how to export the block model. The whole concept of reporting against a volume within Leapfrog, within Edge, is that that volume needs to be inside a geological model. So what I've done, if as an example, where are we? Yeah. So I've got this stope model. Right. So excuse the shapes, but we've got 3 stope shapes that I need to report on. So what I've done is built these into a geological model. It's a simple process, and we've actually got a blog that's coming out soon that explains this entire process, and this pretty much works for any kind of solids that you wish to report from. So if you've got classification solids, so you've got inferred, indicated shapes from another package, just import them into the meshes folder and then just build them in to a simple geological model. And all it is using the new intrusion from surface functionality. You give it a name, so stope 1, and then it runs and it just duplicates exactly the shape that you need, so that it's not doing any interpolation or anything. It's just basically a way of copying these shapes into a model that can be accessed by Edge. So we've got 3 output volumes, stope 1, 2, and 3. So if I bring those up and get rid of the unknown one, sorry, that one there. So now I've got 3 volumes within inside a model. So back down at block models, if I open him up, under the sub-blocking triggers, I've brought that across so that it's going to sub-block around the edges of those, so we get our volumes correct. And then we've evaluated that across. So we just bring the entire model over and it's evaluated. So that means it's now accessible when we run a report. A report is just done by new resource report. And again, I've got one already done. And we can open. So you can store as many different reports as you like. And the process is simply select the columns that you want to access. So I want to report against stopes. So, and in this case, classification. So I could turn that on off, and I'm just reporting my volumes against the stope shapes. If I turn the classification, which in this instance is based on that calculation, it will bring them both up for me. And I'm only reporting against the ordinary kriged grades. If I wanted to add in the inverse distance grades, I would tick that one on. The first time you do it, you usually have to tick on the top and you choose the units, so that this will be red, says no unit. So you just choose the correct unit that you're working in, and that'll make sure that the metal content will be correct. You can choose not to show metal content. You can show density column if you wish. You can show volume columns if you wish. These act like pivot tables once you've got more than 2 elements. So if I want to show this by classification and then by the stope shapes, well, then I just move it across through there like that. You can also apply a cutoff. So I'm just going to turn off, and you can see here that you can choose not to have that piece in there if you don't want to. And I'm just going to turn off the inverse distance again. Oh, there it is. So if I choose to apply a cutoff, I could use that one and say put in a 0.3, and that will apply that cutoff for me. It's just actually about the same as what the other one was. So you can store all different types of these ones. So I'll put one in there. Again, there's no save button. Once it's done, it's done. And then I can come back to that, and that report is saved. So these reports, these SWOT plots, these grade tonnage curves are all stored with the block model. So when we update a new drill hole, that will flow through to the corresponding geological domain that we've used, and the whole block model will update, and you'll see these numbers change. The last part is exporting this. So we right click on there and go export. So at the moment we can export some block models now. We still can't import block models, sub-block models. So if you're importing a block model from another software, you will need to regularize it first, and then you can bring it in. But we can export. So we can export to CSV, or we can export to data mine format, and they're working on SERPAC format at the moment. You just click export to CSV. So we can take it out as a model file that's got the header at the top as included. So it's got the information on the corners of the parent of the block model and the orientation, etc. You can export that so that it's got that head of information in a separate little file, or you can exclude that header altogether and just have the point data. If we do that one, you get to choose which things you want to bring out, so you don't have to bring everything out. You might just want your final inverse distance values. You can choose a query filter so that you can only take out part of the information. You can make sure that you're not taking out anything that's got no grades in it. They usually default these things. Just gives you a summary at the end, and then it exports to a CSV file. You can then import it into your other software. Bearing in mind, if you are importing to, say, Vulkan, and they do have limits on character names, then you will need to set your estimators up with that sort of naming to start with. Otherwise, it won't work. So that's pretty much the workflow for Leapfrog Edge. So I'm just going to go back to one thing. So I mentioned Central earlier. So one way, it's very dynamic, so it's great for grade control and things like that. But if you are thinking of what do I do if I don't, I do an update every 6 months on my resource model, and I really don't want it to change too much. So without Central, you could have 2 projects. So you could have, a geological model project, and then you can have a separate estimation project. Instead of having the whole geological model built in there as well, you would just import the final meshes from your geological model into the meshes folder, and then you will link the estimation part to those meshes. So then you would just update those meshes and it would flow through. Central allows us to do that in a slightly different way. You can see here I have an estimation project and I've got a geology model. So what I've done is under the meshes folder, I have these blue meshes, and these are linked directly to the geology project inside Central. When those are updated, it knows that they are, and this gets a little timer on it, and then you get to right click and go reload from branch, which means from Central, or you can go and pick which project it is that you want to get it from. So this was the last geology model, so I could tick on it. It's not letting me for some reason. But pick on the project I want, and that's because they haven't been updated, so it's no choice there. But if they had changed, I'd be able to pick it, and then they will update. I don't have to do them individually. I can right click on the whole meshes folder and go import from Central, and then it'll update all the Central meshes, and then everything will flow through. So that way people might be working on their geological model every day, but you only need to change the estimate, say, quarterly. So that's one way of keeping things a little bit more static.